Hello everyone, welcome back. So in this video we are going to learn about time constant of a given system. Okay, so if you are first time to my channel, please consider subscribing. So time constant of a system. What is time constant of a system? Suppose if you are having any system, so if you want to find the system behavior, we can found by using this time constant, that is the response or fastness in response of a system is obtained from its time constant. Okay, so generally time constant is given by time constant formula is given by -1 by time constant of dominant pole. Okay, so if what is the advantage in finding the time constant? So time constant is inversely proportional to speed of response. Okay, so if you time constant value, if you find the time constant of a system and its value is more, then speed of the response is slow. That means it will gives response lately. Okay, so if the time constant is less, then it will gives you the quick response. The system gives you the quick response. Okay, so practically any system requires 5 time constants. So practically any system requires 5 time constants to reach steady state. Okay, so any system requires 5 time constants, and this time constant again depends on the system. 5 time constants to reach the steady state. So for any system, after the application of input, you can't get output instantaneously. Okay, this is not possible because all the practical systems does not give the output instantaneously. So it required some time constant to reach the steady state or to give the corresponding correct output. Okay, so in between stage is called as transient period. So that we'll discuss in transient response concept. Okay, so any practical system requires 5 time constants to reach the steady state. Okay, so this is how we can find the time constant. What is dominant pole? So this is important. Dominant pole. So dominant pole is the pole which lies near to the imaginary axis, on S-plane. Okay, so it is having the highest time constant. Okay, so dominant pole is the pole which lies near to the imaginary axis on S-plane. It is having the highest time constant. Okay, suppose if you have a transfer function like this, C of S by R of S is equal to 1 by S plus 1 into S plus 10. So this is the transfer function which you have. Okay, so you have now, as I have told you, if you equate denominator equal to 0, then you will get poles of the system. So S plus 1 into S plus 10 is equal to 0. So S is equal to -1 and -10. So now you have two values for poles. Okay, so -1 and -10. So which pole you have to consider in order to determine the time constant of the system? So that is why we have told you here not as pole but as dominant pole. Okay, so time constant is equal to -1 by the time constant of dominant pole. Okay, so if you draw the S-plane, for this transfer function, where on x-axis you have real part and y-axis you have imaginary part, j omega, and this is minus j omega, this is minus sigma. So both are real parts only, or both the poles are real and or negative. So one is at -10, other is at -1. So as I have told you, this pole is near to imaginary axis. Yes or no? S is equal to -1 is a pole which is near to imaginary axis. So S is equal to -1 is the pole which is called as dominant pole. Okay, so S is equal to -1 is called dominant pole, and the pole S is equal to -10 is called as insignificant pole. That means the system characteristics does not depend on this pole, so that is why it is called as insignificant. So okay, significant or dominant pole is S is equal to -1, and insignificant pole, why we are calling it as insignificant pole? Because the system characteristics does not depend on this pole. Okay, so a pole is said to be insignificant. If its time constant is less than or equal to 5 times the time constant of dominant pole. Okay, so if you take the time constant of S for S is equal to -1, what is time constant? -1 by -1, so -1 by tau. Okay, tau is equal to -1, so you'll get 1 second. Suppose S is equal to -10, so tau is equal to -1 by -10, so it is 0.1 second. 0.1 second is less than 5 times of this. Yes or no? Okay, so it is 5 times of this, so we'll have this. Okay, so this is insignificant pole. S is equal to -10 is an insignificant pole, so you can eliminate that from your transfer function. So final transfer function we can write like this. Okay, so 1 by S plus 1 into, so take 10 common, S 1 plus S by 10. Okay, so 0.1 divided by 1 plus S into 1 plus S by 10. So this is called as we have already seen, pole 0 form is converted into time constant form, 1 plus S tau form. So now we can eliminate this insignificant pole. So the corresponding transfer function is C of S by R of S is equal to 0.1 by S plus 1. Okay, so this is the equivalent transfer function. Now we have only one pole. Now we can say the time constant is equal to 1 second. Okay, or you can also say by finding the time constants of different poles and taking the time constant of the pole which is near to the imaginary axis. So S is equal to -1 is the pole which is near to the imaginary axis. So that is how we can find the time constant of any system. Okay.